Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna. Hi, Fred.
Hi, Dianna. Good to talk to you again. It's Friday as we're speaking with the I don't know, there's some fancy name for it, all these planets aligning tonight. It's not like they're all on one side of the solar system. I think it's just they happen to be aligned, but I suspect they're all on the same side of us.
So the planets are aligned and we're recording an episode.
Yeah.
So it's going to be magical.
It is. And so one of our regular listeners, he said, I would like to learn more about reliability block diagrams and reliability allocation, which are two big topics in and of themselves, and implement them on a new programs, and then ... effectively. And so I don't think we're going to be effective at teaching somebody block diagrams and all the math that could be involved with it, or apportionment in the various options you have, because I think I've done hours long sessions and training and stuff like that on those, and there's plenty of resources out of those. But what caught my eye, Dianna, was the effectively. And you've been there. You're working with a team, and they make a recommendation, or a recommendation gets floated up, or we need to do that, and somebody fills out the form and says, "All right, we're done," and then it has no impact or no relevance to anything. It's a check the box kind of thing, or it's not even done at all, or it's like,
or it's done too late.
Yeah.
And then you can't do anything about it. You can't change your mind. You're too far down the design path. You're like, well, that would have been nice to know 3 months ago. Yeah,
that would have been perfect. But I think that's the crux for almost everything we do in reliability and quality. It's identifying a failure mechanism that really does need attention is really contingent on how well we understand it and what's its impact to the product or the launch or to the field failure rate or whatever, to the business or to the customer, and when, and who do we communicate it with? And I'm thinking of the O-ring failure on one of the shuttle launches. It was, engineers knew about it, but they were not effective at communicating the severity of the risk.
Yeah, there's been a lot of retroactive studies on that. Edward Tufte did a lot of studies about how that communication went down and who made the decisions, and it was the people that were looking at the information and making decisions were highly qualified. They knew what they were doing. They were technically capable. They were good leaders, but there was a breakdown in communicating that. So that's an interesting case study to look into. And I think an important one that all engineers should be familiar with. Anyway, yes.
But let's say we're going to, like with Michelle's, with her request is like, so I'm going to do a block diagram, or a reliability apportionment, which they can be combined as, let's say you have a new product and it's got, a motherboard and a keypad, let's say a computer, the screen, a hard drive, stuff like that. If a block diagram is a series system, it's really, really simple. You just say, identify the parts at the level of detail that you want to go to, and just make it simple. Let's say it has 5 parts, you make 5 blocks, or 5 cells in a spreadsheet. But how do you get the attention of a new team that's coming together to put this together, to say, we need to think through how reliable does each of these blocks need to be, so that we can, as we start sourcing components and start creating designs, to me, that's the most effective place to start that discussion. It doesn't do as much good when it's 2 weeks before launch.
But you can even get one started when you don't. Some people like to push it off until they've made the design decisions, and then they want to analyze it. And I think what you're saying is, and I think once you have an idea of like even if it's just a black box, we
Mm-hmm.
got this thing that's going to have this input, it's got to have this output. We don't know how we're going to do it yet.
Mm-hmm.
Even when you're at that point, that's where these, simplistic reliability block diagrams can come into play, like really early.
Yeah.
And
Yeah.
and you can go back and revise them. They're not set in stone if you decided to add something different. So I kind of look at them as in that phase when you're not quite sure what you're designing yet, or like you said, you don't know the things that you're speccing out, your components, or you don't know which vendor you're going to work with yet, but you have a vague idea. You can start to use that to think about the reliability of your whole system, how you're going to build that in.
Right. And there's a dilemma. What I think, things I found working with various teams is that if you get invited to those concept level meetings and introduce this idea that, well, how reliable does it need to be overall? And, what are the major building blocks of this thing? And it might be, oh, we know it needs a motor. We don't know what style of motor technology. That's fine. Just write
Right.
down motor. Oh, it needs some electronics to control that. Okay. Controllers, and so on. We might not know how many components are on it or anything. That's okay. It's perfectly fine. At that stage, we're just trying to get a handle on, is it even technically feasible for this to occur at this particular, at whatever reliability objective you think it needs to be. But it's the same thought process. Do we need polymer? We're going to use plastic for this, or do we need to use titanium? It's that level of decision making that's where I find it's the most effective. Now, because it, like you said, it's not set in stone, but it gives you guardrails to say, well, if I pick a power supply that is 50% reliable over the first 3 days, that's probably a non-starter. If we have a goal of, say, 90% reliable over 2 years. All right, here's why. Here's the math, guys, anything. So we need to include with how much it weighs, what color it's going to be, what size it is, what are its primary functions is, well, how long should it last without failure? And how are we going to get there? I think one of the problems is when you read a textbook on block diagrams or apportionment, there's all these formulas and guidelines and everything else, and saying, well, you need to figure out that, what is the reliability of that component or of that subsystem. And then you put it in here, and then you do and NOR gates and all the other happy stuff to do all this math. And there you have it. And it's like one and done kind of scenario. Very few of the books I've seen say, sketch it out on a piece of paper at a coffee shop and start.
Yeah.
And then change it as you go.
And I kind of, so my quality background, and sometimes it calls for Post-it notes and a big whiteboard, and it's really to help people think through how relationships, how things are related, so that they can better make a decision.
Right.
And a reliability block diagram is like that. Like if you're a quality tool is a fishbone diagram. Like you might use that if you're trying to find the root cause of a problem or to start eliminating things. Well, if you need to make decisions about reliability, what component or what subsystem needs to have what reliability, like you said, materials, you're choosing materials or vendors. When you get to that point, you can create a reliability block diagram starting with Post-it notes with your team and just kind of block it out. You can move things around. You can change it later. Like if a week later you decided you wanted to change and do something a little bit different, then just take a box out or move it around, and it'll help you make those kind of trade-off decisions in the long term. Maybe that's a concern, that people feel like if they do it, it's got to be technically perfect, and then it can't be changed.
Right.
But it can.
It most certainly can. You're going to change all kinds of stuff in the design. That's why we go through the design process, to do all those trade-offs and compromises and change, and reliability is a piece of that. And it's, in my mind, it's crucial earlier than later.
Yeah.
One of the most effective ones, and longtime listeners will have heard this story a couple of times, but it was, and I wasn't involved in it. I heard about it after the fact. Is this a technical marketing manager was in a new team and basically just did that, used post-it notes or a whiteboard and just created like, right, we're going to have I'll use a generic computer again, right? We're going to have a motherboard. We're going to have this, we're going to have that, whatever. And he goes, all right, overall, we need to make it more reliable than our last one. Our customers are complaining about how many failures we got. So how reliable do we need to make it? And they kind of came to a consensus on their staff team in like 2 minutes. Oh, it needs to be 90% reliable. Or I'll use 95% because I can remember the numbers for this. And he goes, 95%. He says, all right, hard, motherboard team, how reliable can you make the motherboard? What can you estimate right now, just a guess, how reliable you think you can be? And he went around the table to each of the teams and asked them what they think they could do. And they just got a number. And the idea was a discussion, are we even close to meeting our overall goal? Do we even have a chance to do that? And more importantly, which areas do we need to invest in? And more importantly, what areas do we not need to invest in to make improvements? And the program manager quickly caught on to this thing. And she said, all right, on this quick first analysis, it looks like, and I'll pick on power supplies since I love picking on power supplies. Looks like you're the weakest link. All right, power supply team, come back next week with 3 proposals and cost points for how you're going to improve the reliability of your element of the system. And then each week, because it was a series system, each week, one of the teams was low, the weakest link and the least reliable element of it. And so all the burden was on that team to figure out how to make it improve the reliability so that overall they could still meet the goal. And then the low-hanging fruit got dropped off, they then worked at getting better estimates, either from the vendor or internal testing or from field data, if it would apply. And every week, it was part of the discussion of where do we focus resources and effort to meet this reliability goal. But that, to me, was the most effective block diagram I've ever heard of.
It sounds like it, yeah.
It just became part of the rhythm of their decision making. And it wasn't contingent on having perfect estimates or perfect test results. It was pure engineering judgment at the start, just a guess. And then they went off, and sometimes they said, well, we have better data. We can show that we actually are at 98% or whatever. And okay, now you've reduced some of the uncertainty of that. Now you have a real number. Okay. Then where do we focus? How do we improve it? I think in any of the activities we do, and I think you mentioned it, is that sticky notes, and a whiteboard is a great tool to help people focus on making a better decision. And so I think that's the key in my mind, is if you're going to do something effectively, it's got to be tied to something that people actually need to make a decision on and they want to get it right.
Yes. And that's a great example, the story you told about how to use this tool. Mm-hmm. Instead of sitting at your desk by yourself, working out some numbers and then going over to some people and saying, compared to everybody else, your power supply stinks. You need to improve it.
Well, I'm not shy about doing that either.
But doing it in the team setting, where people, everyone can see and make decisions. Mm-hmm. The other thing I've seen work too is, so you have a schematic like that. Mm-hmm. And once you start getting things figured out, you can do a geometric layout, just what's going to be sitting next to what. Mm-hmm. And after that, you can do an interaction diagram. So now you can say, all right, well, now the motor's sitting next to this circuit board, and there's going to be a vibration interaction there.
Yeah.
And then and then this part's sitting next to this other part, and there could be some heat interaction. So now, So now you're dissecting still at concept. You haven't really, your design isn't solid yet, but now you're identifying some of those stress points that could cause and affect the reliability of whatever you're designing. So then that's kind of like the next step.
Well, that gets after that. I've heard one person call it, it's the white space in your design. You have a functional design block diagram, you have a, a physical block diagram, and here's where but now we're talking about, here's where the wires and vibration and heat go. Where is
Yes.
and that catches a lot of teams off guard. They make a perfect power supply, but it doesn't work with your hard drive because you haven't made any prototypes to try that yet. And you just hadn't thought through that. Is there a timing thing? Is there some other issue that between these two that they don't work?
And that can, go back and affect your reliability. Maybe that will, reduce your reliability of one of your subsystems because now you have new information. Now you come farther along in your design, but yet not so far that you can't change it. And then that affects the reliability blocks, and then you can continue to make decisions with how to best do it.
Well, that makes me think of, I saw one block diagram that the reliability engineer was incredibly proud of it. It took a large wall to show it to me.
And they can be fun to put together. Yes.
And it was, all these different things. And they had blocks for the interaction pieces. They had blocks for every wire and cable and connector. They had blocks for just about name anything that could be associated, say, with their computer. There was a block for it. And then they had another block for, just in case. I think it was JIC. And I'm like, what's that? What kind of component is that? Well, that's my slush fund, because there's stuff we still don't know. And I thought, well, that's a brilliant idea,
So they put in a placeholder for we're not quite sure yet?
Yeah, it's for the uncertainty and the estimates and the rest of them. So we're going to take up some slack here. And as we, like you said, as we learn stuff, we've got to allocate for, are we going to solve that failure mechanism, or do we have to account for it? Yeah, the model was totally impractical. It reminded me of a science fiction story where they had a model of societies that, that it took decades and decades to even understand what it meant and stuff like that. And it was a super duper model of everything in the world. And two people ever understood anything about it. That's fine if you're in a research group doing crazy models, but if you're actually trying to design something, you don't have time for that.
Yeah, and that's an important point, that it's a communication tool and a decision tool. So if it's so complicated that only you can understand it, then I mean, sometimes just going through the analysis will give you some ideas, but then I don't know, it's better to do with other people.
Yeah, no, I totally agree. And it's, don't put it on the PowerPoint and say, oh, here's our block diagram. We're done with that now. That's least effective, or just not doing it because you think it's too complicated. Right. I think it's, like you said, get just a whiteboard. And I think the key is that you connect it to, we need to decide how we're going to get to our system reliability objective, for example, or whatever that tool is. How do we know which vendor to choose? Well, then what are the driving factors to make that decision? Then pull out the tool that applies. And it might be a block diagram. It might be an FMEA. It might be something else. But it's start with, what do you need to know? What's the decision, and what kind of information you need for that? And what this technical marketer said is like, the last product we did out there just was not good. We missed the boat on that one. We know our customers really care about reliability, so let's get it right. So how reliable do we think we need to get it so that the warranty is appropriate and we don't have too many field failures and so on? He started with that. And then it led to that ongoing discussion of where do we need to focus. And the tool itself was just a mechanism for them to talk about it. It wasn't an end in itself. And I think creating a beautiful block diagram and nobody looks at it, or nobody talks about it, nobody makes a decision related to it, is missing the idea. Is use that as a vehicle to support decision making. And it's fill in whatever tool you want. It has to fit the need rather than we have a tool and we're going to force it into this program.
And then, you can make it pretty for posterity's sake later. So that if you get to the end, and you're looking at, well, we're doing the next one, did we meet our expectations?
Mm-hmm.
Or were we a little short on something, and why? So now I guess you're looking at how you designed it versus what's in the field and how it's performing, and you can evaluate, is your design system, is it robust, or do we need to learn better how to do certain things, or how to test a certain aspect of our components so that we can do better next time.
And that's a really good use for a system model. In block diagrams is a common one. Is, all right, here's where we think we got to in achieving our goal or exceeding it slightly. Yet we know that there's uncertainty with every one of our estimates going into it. And then start tracking your field data and mapping it against your goals at the level you use to make those design decisions. It's wonderful feedback. One of the hard parts is that team is typically off working on the next project, or they're dispersed onto various projects. And so it's the sustaining engineering or the production teams and so on. They may have some design options and so on, but they're just trying to get product out and avoid problems.
Right.
In the block diagram may give them some ideas of where to focus on. That's a different problem. Is where,
yes,
how do you align feedback to the design team when they don't care about that other product anymore? They're off doing something else.
But if they care about how they do the design,
mm-hmm.
then they would want to make that an intentional thing that they follow up on.
Yeah. And that was I think the telling tale. That's when I heard about it, is this team that did this weekly discussion about the weakest link, basically, found that when they launched, after 3 months, they had not only met their goal, they exceeded it. So instead of 90% or 95% reliable, they were like at 98% reliable.
Oh, so they were a bunch of pessimists, huh?
Yeah, they were all holding back, not wanting to commit too much, I think. But then they found that really worked for them. And so the program, and that's why I even heard the story, is they wanted somebody, and I was at a corporate group doing webinars and stuff like that. And they approached me saying, hey, can we, share this story of how effective it was and how useful it was. And so, I mean, I'm still talking about it, and it's 20 plus years later.
Did they do a case study or anything? Or
they did a webinar, and they and they said they had a handful of people. They had it's a whole different podcast though. And it's like, because they had people, that'll never work for us. We don't like each other, so we don't talk to each other. I mean, that kind of stuff. And that only worked for you because you had just the right mix of people and blah blah. It change management in general, but having a success story. The handful of teams that had managers says, that just makes sense. Probably went on and implemented it in various ways and saw success in it in one form or another. Yet it was the right tool at the right place for a team that got it. And then you're effective. So that's maybe that'd be the summary of this one, Dianna, is if you're going to recommend using, say, a block diagram, it's got to be for the right team at the right time, and they understand it. So got to get all the conditions right. So we'll end on a pessimistic note here.
Well, I'll change it to optimistic.
Okay.
Is that you don't have to make it complicated to get started.
Yeah. No,
so if you're in the moment and you're kind of seeing that, hey, my team can really benefit from this, I would say go ahead and propose it to the team.
Mm-hmm.
And then even if you don't quite remember what you do with the OR gates versus the AND gates and that kind of stuff, you can just be honest and say, you know what, I'm going to look this up and we're going to, back calculate. And when we get back together, we'll make some decisions. And I think that's acceptable to do. I mean, you don't have to know all of the ins and outs of it just to get started. you can look it up as you go. Because like you said, there's a lot of textbooks with how to do it.
How to do all that stuff. And in my experience, the vast majority are series systems, which you should be able to figure out pretty on the fly because it's multiply the reliabilities together and you're done.
But I'm being the optimistic can do, Fred.
Yeah. No, if you've got, and the more complicated systems that have some levels of redundancy and so on, then you got to get a little bit more technical because the math then does matter. You can figure it out as you go, get it started and get the discussion going. I think that's for almost anything we do, that's what's important. And supporting decisions is the key. But anyway, if you've got, one of the things telling that story about this, use of a block diagram and being so successful, I know there's more out there. So if you're listening to this and got a tale of just, this is perfect story of how to use this tool or activity or method, let us know. Or if you got questions about how this team actually did it, that'd be good too. So let us know. Head over to accendoreliability.com/go/SOR, and you'll find a couple of ways to get in touch with us. Dianna and I and the other hosts are available through LinkedIn and our About pages. So plenty of ways to get in touch with us. I'm trying to think. I think I have a team meeting this afternoon. Now I'm going to just whip out a block diagram on them, see how it goes.
Oh, yeah? All right.
Let's see. Might be a subject for another podcast.
I bet it's going to go great.
Yeah, well, so there you go. You are ever the optimist. I love it. Thanks so much, Dianna. Talk to you later.
Bye, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.